they're going to use maybe a rectangle.
We're going to work on optimizing area with perimeter. And what we're going to do is our constraint will be our perimeter in this question. Okay? So what they're telling us is we have a set perimeter. The question says we have 900 meters of fencing. It's quite a bit of fencing. Okay? And we want to enclose the largest possible area. So we're going to go through a few shapes. We won't go through every single shape. Okay? But we're going to go through a few. And what we need to do is figure out maybe what shapes will most likely be most efficient. And then when using those shapes, what ratio is very important for us. So I'm going to start with a four-sided shape because normally when we talk about enclosing areas, we tend to use maybe rectangles, stuff like that. So we're going to compare a rectangle here, and we can really give it any size. So we're going to have a rectangle, which means two of the sides will be longer than two of the other sides. Okay. And we can set up any ratio we like for this question here. And we're going to compare it to another four-sided shape. I'd like to compare it to a square. Okay. So, for a square, how would our our fencing have to be divided? A square has four sides that are the same.
Square root of 900 divided square root of 900.
Well, that is the total perimeter. The total perimeter here is 900. So, for instance, what is the formula for perimeter of a square? Does anyone know? Perimeter.
Yeah, length times 4.
That's right. For a square, we can do length times 4. We add them all together. Because it's a square, they're all identical. Right? So if we were to go L plus L plus L plus L, it's the same as saying, and it's going to be equal to 900, 4L equals 900. So what is one of our lengths going to be? It will be 900 divided by 4. What is it? Is that exactly what it is? Yeah, 225. Let me take a look at 0. 4, 8. Yeah, it is. Great. Okay, so in this case, we have 225, which will be by 225. So this was the perimeter. We just used perimeter of a square. Area of a square is a little different. Area of our square is equal to length times width. Now, in a square's case, they're identical, so you could say L squared if you like. So let's go with 225 squared. It'll be probably a relatively large number. Let's bring up a calculator. 225 squared, 50,625. 50,625. And it was meters squared. Okay. I'm going to choose a rectangle here. And we're just going to give two sides here. We'll call this maybe 200 and 200. And if I call both of these 200, I've used 400 meters of fencing. So how much fencing do I have for the top? That's right. How can I... Excellent. Very good. So this is close to a square. Okay, but it's a little different. Okay, and I've just chosen these. I've broken them up. I didn't use any mathematical equation for them. I just broke them up because I want us to see the difference here. So the area of a rectangle is length times width. And in this case, we get 250 times 200. What is it, 50,000? Okay. Is that larger or smaller than the square? Okay, that's right. The square gave us more area. I was able to enclose a much larger area. And this idea, the farther we get away from a square into maybe a very elongated rectangle, the less area we're going to get. Okay? Okay. So, what that means is for a four-sided shape, what is our most efficient shape? A square. A square is most efficient. But let's compare this to other ones. What if I were to say create a triangle? And, sorry, I did want to talk about this idea. What does that probably mean when we're talking about other shapes? If I make a triangle, okay, what kind of triangle is probably going to be the most efficient in enclosing area? Equilateral, right? It's going to be very similar idea to the square. All the sides will be the same, right? So, we're going to narrow it down to use just specifically an equilateral triangle. Hopefully, those look about the same. Okay. We know in our equilateral triangle, the perimeter, all the sides will be the same. So the perimeter of an equilateral triangle ET, okay, will be length plus length plus length, which is 3L. What was our perimeter? What was our constraint? 900. So what are the lengths in this case? That's right, 300. Now, this is a little harder to calculate. Does anyone remember how we do calculating of a triangle, or the area of a triangle? What do I still need to know? I need the height. Okay. Now, luckily, an equilateral triangle, and it's not work for every triangle, but an equilateral triangle, the height will be directly in the middle, which means we can turn this into a right-angled triangle to figure out some information. If I'm cutting it in the middle, how far is this? That's right, it's only half. Good. I need to figure out the height. What formula can we use to figure that out? Pythagoras, that's right. We have the hypotenuse, and we have a side. So let's use Pythagoras. We know that is c squared is equal to a squared plus b squared. Okay. And in this case, we have c. C is 300. We'll say a is 150, and b is what we're trying to figure out. Oops. Should be a plus. Okay. So this ends up being 300 squared. Subtract 150 squared is equal to b squared. Let's work that out in the calculator. We have 300 squared. Subtract 150 squared, which is equal to 67,500. 67,500. And we know in order to find just b, the height, we need to square root that value. So the square root of this value, 259.8. We'll try to be very accurate here. 200, sorry, was it 58 or 59? 59.8, okay. 59.8. Okay. We probably could round it to 60, but it's not technically true, and we are working with a restriction here. So we want to be as accurate as possible. So our b in this case, which was the height of this triangle, is 259.8. We know that our area of a triangle is equal to 1/2 times the base times the height. Okay? The base in this case is 300, and the height is 259.8, and then times 1/2. So 1/2 times 300. What was the height? 259.8, roughly 260. Okay. So I'll take that number, I'm going to multiply it by 300, and then I'm going to multiply it by 1/2, which is the same as multiplying by 0.5. 38,971. Is that even close to our other ones?
Nope.
Our four-sided shapes gave us much larger areas. Okay, as we noticed, this was 50,000, or over 50,000, the other was 50. So a triangle is not very efficient. Okay, and I want you to get closer to this idea. The next shape we're going to use is probably and is the most efficient. Anyone know? Can guess? Circle. The closer we get to a circle, okay? So a triangle is almost the farthest you could be from a circle. There's only 3 sides to it. A square is getting closer. What's after a square? How many sides are there? Pentagon. You'll notice it's starting to take on a more circular shape. Then we could do a hexagon. Okay. Yeah, and then technically it's a septagon, octagon. We're getting more and more and more circular. And all of these areas will enclose larger areas for us under our constraint. But a circle will be best. Okay? A circle will be best in this case. So let's figure out the area of a circle. For instance, perimeter is not really called perimeter on a circle. What do we usually call that? Circumference. That's right. So circumference of a circle is diameter times pi. Okay? Or you could say 2r if you're working with radius. Our circumference is 900. We have 900 meters of fencing to go around this circle. So our c is 900. And we're going to find d. Remember, pi is not a variable. Pi is an amount. We know the exact amount of what pi is. So in order to find d, we need to take 900 and divide by pi. So 900 divided by pi equals 286.47. 286.47, which is equal to our diameter. We do. Okay? That's the diameter of the circle. What is area of a circle? pi r squared. Now, do I have r? Can I figure out r from what I have? That's right. We do need to. We need to turn it into radius. And to turn diameter into radius, we divide by 2. That's right. So we'll divide this by 2 to find out what our radius is. Take this same number in the calculator, divide it by 2. 143.23. 143.23. Excellent. So we now have our radius. Let's plug it into our area formula. Pi 143.23 squared. And then we'll have to do that times pi. So I take this value. I square it. And then I multiply it by pi is equal to 64,456. 64,457. This is meters squared. I don't know if we can see it all in one shot here, but how much greater? Look at this, 64,000. Our square only did 50,000. So the closer we got to a circle, the more area we were able to enclose. Essentially saying that a circle is the most efficient